day, everyone. Our concentration is on the tangent chord theorem, or also known as the angle on the circle theorem. Statement of the theorem: the measure of the angle formed by a chord or a secant and a tangent intersecting at the point of tangency is half the measure of the intercepted arc. Let us take note of the illustration at the right. We have a circle A. We have their tangent BF. It's actually a segment intersecting the circle at point D called the point of tangency. We have CD, that segment there, is a chord intersecting the tangent at the point of tangency. There are actually two angles that are formed. We have the angle BAC, which is this angle here, and we also have the smaller angle, which is angle CDF. We will concentrate on the green angle. Measure of angle CDF, the green angle, is equal to 1/2 the measure of the arc CD. Arc CD is the arc intercepted by the angle. That is in the yellow arc. Let's see why this is true. Using the same illustration, circle A with the tangent segment BF at point D, chord CD intersecting the tangent segment at point D. Let us draw a diameter from point D passing through point A, which is the center of the circle, and point E. We now have segment ED as the diameter. Because of this, we can say that the measure of angle EDF is equal to 90 degrees. Why is that? It is because of the tangent line theorem. If a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. Let us mark that angle, that 90-degree angle, with the symbol for a right angle. That is the angle. That's angle EDF. Again, let's take note. Here is the radius AD perpendicular to the given tangent BF, thus making our statement number 1. Let us also draw a segment that is connecting point E and point C. That is the yellow segment. Thus, we are forming angle C. What then would be the measure of angle C? Angle C is 90 degrees. Why is that so? Let's mark that angle C, which is a right angle or measuring 90 degrees. Again, we can say that angle C is a right angle because an angle inscribed in a semicircle is a right angle. Where is that semicircle? Trace from point E to point C to point D. That is the semicircle. And opposite that semicircle is the diameter ED. So we can say that angle C is a right angle measuring 90 degrees. Why? Number 3, measure of angle CED plus the measure of angle EDC is equal to 90 degrees. Where is that angle CED? Angle CED is the blue angle here. EDC is the brown angle here. Why can we say, why can we add their measures and say it adds up to 90 degrees? Now let us take note that when we drew the segment EC, there is a right triangle that is actually formed, that is triangle EDC. And since we have a right triangle, then in a right triangle, the measure of the two acute angles or the two acute angles are complementary. And what do we mean by complementary angles? These are two angles whose measures sum up to 90 degrees. Thus, our statement number 3. Also, if we take a look at the right angle, EDF, this is the right angle here, it is actually comprising of two smaller angles. What are these two angles? You have angle EDC, which is the marked angle brown, and you have the angle CDF, this angle here, is the CDF. Why can we say that that comprises now the angle EDF? By the angle addition postulate, you have EDC plus CDF is actually the right angle EDF. So we can say that the measure of angle EDC and the measure of angle CDF will also be the same when added together, will be the same to the measure of angle EDF, the right angle here. And since we have previously statement number 1 and we have statement number 4, we can proceed to statement number 5 by substituting the measure of angle EDF here to 90 degrees. So we have statement 5, the measure of angle EDC plus the measure of angle CDF is equal to 90 degrees. Taking into consideration your statement number 3 and statement number 5, we can see here that the measure of the sum of the two angles in number 3 is 90 degrees. The measure of the sum of the two angles in number 5 is also 90 degrees. So by transitivity, we can say number 6 statement, the measure of angle CED plus the measure of angle EDC will be equal to the measure of angle EDC plus the measure of angle CDF. That's by transitivity. Let me just clean it up. Then we proceed. Let's take a look at number 6. You have here the measure of angle EDC, and also you have here the measure of angle EDC. So if we remove that measure on the left side and that measure on the right side by subtraction, since they are equals, we will be left with the statement the measure of angle CDF is equal to the measure of angle CED. Let's mark that in the figure. CDF is actually, again, this angle is your CDF. And you have here angle CED. CED is this angle here. We can actually say that they are equal in measure or they are congruent. Why? From the previous statement number 6. And from number 7, take note that the measure of angle CED or the measure of angle, yes, the measure of angle CED. Let's take note of the measure of angle CED is 1/2 the measure of the arc CD. Why is that so? This is your CED angle and opposite that is the arc CD. CED, angle CED is an inscribed angle intercepting the arc CD. So by the inscribed angle theorem, we can say that the inscribed angle is actually 1/2 the measure of the intercepted arc. And connecting your statement 7 with your statement number 8, the measure of angle CED be substituted with the 1/2 is equal or 1/2 the measure of CD. We have statement number 9. The measure of angle CDF is equal to 1/2 the measure of angle CDE. Let's take a look at in the figure. CDF, angle CDF, which is this angle here, is the angle that is actually formed by the chord CD, this chord here by the chord CD and the tangent segment BF. And the intercepted arc is arc CD. This is the arc CD, which is actually the theorem, the tangent chord theorem, that the measure of the intercepted arc or 1/2 the measure of the intercepted arc is equal to the measure of the angle on the circle. Again, the tangent chord theorem says the measure of the angle on the circle formed by the chord intersecting the tangent segment at the point of tangency is equal to 1/2 the measure of the intercepted arc.